The next one. Someone making low temperature a hot topic. Oh, you're sitting right there. Yeah, you? We're going to have Thermagix come up right now, and it's going to be Gil Aginski, CEO.
Hello, thank you for having me today. Happy to be here. I'm Gil, the CEO of Thermagix. $1 trillion blind spot surrounds us. Wherever you will look, you will find it. Now I'm talking about unlocking the value of low-grade waste heat. 50% of the produced energy in the world becomes waste heat. Most of it is below 100 Celsius. Below 100 Celsius, there is no economic solution for harvesting. And if we will add to it the need for robustness, for example, we don't want to be dependent on the grid, efficiency, 50% getting lost, cost, very important, of course, environment, an operation that you want to scale, but again, you want to scale without the dependent of outsource energy like fuel or gas that is lacking in some areas, and resilience, which is again very important for us, and you add it to the zero economic harvesting solution, you have $1 trillion blind spot. And this is where Thermagix actually enters the picture, using phase change thermoacoustic technology, our technology, that has outstanding heat dissipation capabilities for data center, for example, that will save money on electricity and water. We can turn your waste heat into electricity and or cooling in a very cost-effective and eco-friendly manner. For example, we will take the heat in your yard and produce electricity for your own use, so you will have your own source, energy source. Our technology has no moving parts, so it's very robust. It's fully modular and scalable. For example, you can see in the center of the slide a 9-unit rack that can be scaled according to the need. Very efficient, more than twice than the efficiency of a regular combustion engine, and the heat transfer is very high, talking about 1 kilowatt per square centimeter, and no emissions whatsoever. Very attractive ROI, 2 years, and the OPEX nearly to zero. You have already paid for the fuel, which is the excess heat, and no moving parts, no maintenance. The business model, system sale, and recurring service revenue. In a nutshell, thermoacoustic is a proven technology. We take the heat, put it inside the system, produce sound wave, and then decide if to use to produce electricity or cooling. And it's a very expensive technology that is being used by NASA. And Thermagix actually introduced the phase change that reduce the pressure and the heat, so the capex dropped down dramatically. We got funded, TRL4 almost 5. We got traction in several shipping and heavy industries and data centers. We're part of Intel Ignite. Team is very, sorry. The team is led by academic and business excellence, and we are seeking for visionary partners ahead of our Q4 round to bring Thermagix to mass production and unlock the $1 trillion waste heat revolution. Thank you.
Thank you, Gil. That was fascinating. Can you tell us a little bit about your traction, go-to-market, business model?
So we got several LOIs from shipping and industries for buying the units, according, of course, to the heat source that they have. So we are trying to increase the number of the LOIs right now, but we are already on track with several LOIs. And like I said, we are selling the units. Right now, we are in shipping, heavy industries, and data centers.
Gil, thank you for this talk. Can you talk a little bit about the demonstrations that you've already placed? Where did you put them? What was the output of those demonstrations?
So we are at TRL4 almost 5. In about a month, we will put our first demonstrator in the industry in Haifa. And by the end of this year, we will introduce 2 MVPs. The first one is in the heavy industries, and the second one is in the ship. We already have the ship. We already been in the ship, did the ICDs with the ship. It's more complicated, so we started early, but it's going to be by the end of this year.
Can you give some numbers? What's the size of your, in kilowatts of your unit, this demo that you have done? And second, what sort of efficiencies do you get, let's say, from heat to heat or to cold?
So right now, the demonstrator that will be introduced in about a month is a very small one. I'm talking about 40 millimeters of a demonstrator. So it's something like 20 to 40 watts, that's all. And the efficiency that we are aiming right now is 20% of Carnot. We are trying, and we will get by the end of this development to 50% of Carnot. And the demonstrator that we will put by the end of this year is about 300 millimeters, and it's about more than 1 kilowatt of electricity production. We are working with 140 Celsius. This is the demand of the customer, actually.
Thank you, Gil.